We have a system of congruences with relatively prime moduli, and that's sometimes referred to as coprime. What does that mean? It means that B and D don't have any common factors other than 1, okay? Relatively prime. For example, 8 and 3 would be relatively prime. If B and D were 8 and 3 respectively, they would be coprime. And again, relatively prime is a common substitute for the term coprime. Now, this is important because it establishes the existence of what they call multiplicative inverse here, y sub 1 and y sub 2. If these aren't coprime, you don't necessarily have a multiplicative inverse. So that's the basis for that. Now, let's go ahead and verify that this posited constructed solution is indeed a solution. Now, right here, this piece right here is manifestly congruent to 0, right? Any multiple of B is congruent to 0 mod B, okay? It's congruent to 0 mod B. So this term goes away, and now we have the dy sub 2. But notice that dy sub 2 and y sub 2 exists. Just this piece right here is congruent to 1. And so it's kind of trivial in a certain sense to establish the veracity of this constructed solution. And so we get just this whole long expression just reduces to A mod B, and that makes it a solution to the very top equation up here, to the very top equation in the given, okay? Now, it's very, very similar for this bottom part. So the very, very same thing right here, you would get what mod D, this piece right here would be congruent to 0 in this case, right? There's kind of a symmetry going on here. This entire piece would be congruent to 0 since it is again, manifestly a multiple of D by form alone, and the modulus is D here. All right, and it again, by sub 1, just this part right here is congruent to 1, right? So you see, in some sense, this is very trivial if you use your notation properly, and believe that congruence behaves very much just like the regular equality relation. All right, so we've proved what we set out to prove in terms of just the general case, but let's work a concrete example. Okay, now here we have an example. Notice that 8 and 11 are relatively prime. And this assures the existence of multiplicative inverses. All right, so now down here we see that 8 times 7 is 56, and 56 minus 1 is 55, and that's divisible by 11, right? Again, I'll write it like this. You could write it as 11 divides. Y'all are familiar with this vertical bar that is the divides operator. 11 divides the quantity 8 times 7 minus 1, right? 8 times 7 is 56, minus 1 is 55, and 11 divides 55. All right, and in a similar fashion over here, this is even easier to see, right? 33 minus 11 times 3 is 33, minus 1 is 32, and so I'll just write down 8 divides 32 here. Okay, so that's pretty cool because you see these would be our y sub 1. This is our y sub 1, as you can tell by the way it's written here. This would be your y sub 2. So our constructed solution would be 379, okay? And that's pretty easy to check in here. You guys, you can check that if you want, but you can get an even smaller solution. 379, again, you guys, well, right here, that would just say that 8 divides 379 minus 3. Now, 379 minus 3 is what? 376. Okay, 8 does divide that number. Let's see, 8 times something, what? That would be 47, right? 8 times 47 is 376. Okay, and this one's easier to see. Right here, you would have 11 definitely dividing 375, right? Okay, so we've shown that 379 is a solution to this this congruence up here. Okay, so x is equal to 379 is one solution. Let me just write that up here. So x does equal to 379. Now it turns out there's an infinite number of solutions. Anything that's congruent to 379 mod 88. Okay, let's just take a look at that real quick. 379. Let me here. We got enough room right here, right? So 379. Okay, is equal to 3 times 88. Let's see, 3 times 88, 4 times 88. Okay, it's equal to 4 times 88 is 352, right? So 4 times 88 is 352. That's 320 plus 32. And then, so again, 4 times 88 is 352. And then, but if you add 27 to that, 27, right? I'm sorry, 350, 27 and 352 is 379, right? But notice that those are solutions, you know. So x equals 27. 27, you can see very clearly that 27 is congruent to 3. Mod 8, right? And also 27 is congruent to 5, mod 11, because 27 minus 5 is 22, which is divisible by 11. Okay. So y'all, this would be the least residue, I guess, least positive residue or whatever they call it, you know. Mod 11 here. And y'all, again, hopefully it's clear where the 88 comes from. The 88 is the product of the two coprime moduli. Okay, so this would be kind of probably like the test question that you would get, right? So 27 is another solution. You could ask for the greatest negative residue if you wanted to and just subtract 88 from this. If it felt like it, that would give you something, right? So what would that be? Minus 59 or something? Okay, so so x equals 27 is also another solution here. And again, that's a common type of test question. This was just a construction of a solution, but it's not, rarely would it produce the least residue, I think. But anyway, that's all. Hope you guys enjoyed. Thanks for viewing.